Okay, this is part 1 of your test review. I'm going to start with number 8. I'll come back and talk through 1 through 7 if I have time. I may not have time to make all those videos. I think that y'all are okay on that stuff, though. If not, then you can email me or text me a question. But I'm going to start with these. Okay, so to find my horizontal and oblique asymptotes, those are things that are done after I have reduced. What I do before I reduce is domain. Really, for horizontal and oblique or slant asymptotes, I can do it before I reduce, and it doesn't really affect it. It does kind of affect the idea of what's happening, but you should get the same answer. So if some of these need to be factored and aren't factored yet. So number 8, I can't really factor it anymore. They are tied in degree, numerator and denominator, which means I just take the ratio of the leading coefficients to get my horizontal asymptote. So it is y equals 3. If I have a horizontal asymptote, I cannot have an oblique asymptote. Number 9. So I have holes here because I can cancel this out, so there's a hole at x equals 0. So that just leaves me with 3/5, which is a line. It's a horizontal line because it's a y equals 3/5 line. But just like we talked about today, that's still an asymptote because still the, we're still tied in degree in the numerator and denominator, so I still have a horizontal asymptote of this ratio, so it is y equals 3/5. Same idea is with our slant or oblique asymptote like we talked about today. So the asymptote is the line because what the asymptotes give you is the end behavior. At the end, it is approaching 3/5. And it's actually at 3/5 the whole time. All right, so then number 10, I need to factor it if I can to see if I can reduce anything. And the numerator does not factor, so can't do that one. And then, and even if I didn't reduce it, I would get the same answer. So I have a linear binomial here, which means I'm going to do synthetic division. I could do long division. Synthetic division is less messy. I can't do the short division, though, so I'm going with synthetic division. If you did long division here, it does not make it wrong. Remember, though, when you're lining out your numbers up here, make sure you put placeholders if you need them. I don't need them for number 10, but some of y'all are still forgetting that, and then that's throwing you off. Don't care about the remainder. So I bring down my 4. This becomes -20, so I get -21. Don't really care about the rest, so I don't even need to do it. This was 1 degree higher. That's why I divided. I sort of skipped over that explanation, which means I don't have a horizontal asymptote because it's top heavy. I do this to get my slant or oblique asymptote, and it's y equals 4x minus 21. All right, so number 11. It is top heavy, which means there is no horizontal asymptote. I'm not going to bother factoring the numerator, even though I could, because that's not going to really help me here. That thing's going to cancel. That'd give me my roots and stuff, and that's not even in the question. Here I can do the short division. I mean, I can do a different way, but you just get this out. I don't care about the remainder. So this is going to give me y equals 3x squared divided by x is 3x, plus 2x divided by x is 2. All right, so then 12 can factor this out. This is going to give me x times a -2x over x times x squared plus 1. So I have a hole at x equals 0. Those cancel out. I'm still bottom heavy either way, and so my horizontal asymptote is at y equals 0. And there is no oblique asymptote. So now we're going to be looking for domain in the holes. So remember, domain is what we do before we reduce anything. And the domain for rational functions is all real numbers except for whatever makes the denominator 0. And so my domain for number 13, x cannot be equal to 5. And for 14, x cannot be equal to 0 or 4. For number 15, x cannot be equal to 0 or 8. And for 16, x cannot be equal to -2. Okay, so the domain is the only thing you do before you reduce. So now I got to see if I can cancel anything out and find my holes or my point discontinuity is what I'm looking for here. So nothing I can cancel out here. So since there's not a common factor in the numerator and denominator, this doesn't have any. On number 14, I can reduce here. So that means that I have a whole when x equals 4. So then I have to evaluate it at x equals 4. So when x equals 4, I get 4 plus 4, which is 8, over 4, which gives me 2. So there's the whole in my graph. Here, this is nicely already all factored for me. Nothing I can reduce, so there is none here. This one here, I can reduce here. So I'm left with x minus 3, and that means I have a whole when x equals negative 2. Then I have to evaluate at x equals negative 2, so when I plug in negative 2, that gives me a negative 5. Now remember, like we talked about today, this leaves me with what's going to look like a line with a hole in it when I graph it. And this question does not ask about an oblique asymptote, but it does have one. And the oblique asymptote there is y equals x minus 3, because the asymptote and the line are the same thing. Okay, so now I'm going to look at the vertical asymptotes. Vertical asymptotes is when I look at the denominator that's left, it's after reducing, and whatever makes that 0. So the vertical asymptote is the line x equals negative 5. For number 14, it's x equals 0. 15, I have two of them. I have x equals 0 and x equals 8. And then nothing here in number 16. All right. Now let's look at number 17. We're going to find the x and y intercepts of the following rational functions. Okay, so remember, domain is the only thing that you do before you reduce. And so if I have a common factor in the numerator and denominator, which I do here, I'm going to cancel these out because I have point discontinuity when x equals 4. So when I go to look for my x-intercepts, that's when I take the numerator factors and set them equal to 0, but x minus 4 doesn't count anymore. That's a hole, there's a hole there. So that goes along with Zeke's question today that I hadn't really thought about. Like if I have a hole, and the question today on that quiz was, if I have a hole that is the y-intercept, then do I really have a y-intercept? And no, I really don't. That the function approaches that point, but it doesn't actually intersect it, so it's not really a y-intercept. So I didn't want to really give you a straight answer on that until I confirmed it, but that is confirmed. And then I realized even on the review that I had worked out, I had marked mine out on one of them. Apparently I already had that thought and forgot about it. So since if I look just at the numerator before I reduce, then I would have two roots. I'd have positive and negative 4. But since I'm canceling these out, there's a hole there when x equals 4, so it cannot be a root. It does not cross the x-axis there. It is not part of the domain. So I actually have one x-intercept, and since it's asked like this and not for zeros, then it is at negative 4, 0. It is an ordered pair. My y-intercept, I plug in 0 for x, and I'm going to get 0 4/3. Alrighty. So then number 18, I need to go ahead and factor. So when I factor the numerator, I need two numbers multiply to give me negative 21. So that will be x plus 7 and x minus 3, because that'll give me that 4. Then I get this x minus 3. So again, these cancel out. Okay, so I'm left with x plus 7. I have a hole here, so since I have a hole here, that cannot be one of my roots. It is not one of my x-intercepts, so it's just negative 7, 0. When I plug 0 in for x, I get 7, so it's 0, 7. On this one here, I need to try and factor it. Well, two numbers that multiply to give me a negative 4 and combine to give me a negative 1. I can't think of any of those don't exist, so it doesn't factor. Just because it doesn't factor doesn't mean I don't have x-intercepts. Not really concerned with the imaginary numbers. So I know when we use the word roots, we can have imaginary roots. You can't really have an imaginary x-intercept. So we're just looking for the ones that we can actually graph. But it doesn't factor. I got it. So I'm not going to cancel anything. So that's good to know. But I need to do quadratic formula here, see what I can find. So x equals negative b. I promise I won't sing the song. So negative b plus or minus the square root of b squared, so that's 1, minus 4 times a times c, and that's negative, so it's really plus 16, so it's not going to be imaginary, all over 2. And so that means that I have 2 x-intercepts, and since I'm having to write them as an ordered pair, then I can't really write it as the plus or minus in my little set notation. This is going to give me 1, oops, not so much that, 1 plus the square root of 17 over 2, comma 0, and 1 minus the square root of 17 over 2, comma 0. Then my y-intercept, when I plug in zeros for my x's, that's going to give me a positive 4/3, so it is 0, 4/3. I'm going to do this graph here, and then I'm going to stop this and go to a second one so I can let this one process. Alrighty, so you want to start with your domain, and even though the domain happens before you reduce, that's why it's before this in our list here, we still need to go ahead and factor. So this is going to give me 2x over x times x plus 5. Okay. So my domain is going to be all real numbers except for x cannot be 0 or negative 5. Okay, so then I see if I can reduce. I can reduce. I can cancel those x's out, which means I have a whole when x is 0. And then this gives me 2 over x plus 5 is my reduced rational. So when I plug in 0 for x, then that's going to give me 2/5 as my y value. So there's a hole in my graph. Then my roots. My roots, I take my numerator, set the factors equal to 0. That doesn't really work out for me there, so there is none there. Vertical asymptotes, set the denominator equal to 0, so x equals negative 5. Tangency and togetherness. Do I have a factor that's squared in the numerator or the denominator or both? And I don't, so this is none. My end behavior, my horizontal asymptotes, this is bottom heavy, so it is y equals 0. And if I have a horizontal one, I do not have a slant. And then my y-intercept, okay, and this is the one where even on my own paper, I don't know why, I have 0, 2/5, because that's what I found. But then, that's the same number as this, right? So since I have a hole there, that point actually doesn't exist on my graph, so there isn't a y-intercept. A lot of times when there isn't a y-intercept, that's because you have a vertical asymptote at x equals 0. That's not what's happening here. You just have a hole there. I think most of you, except for maybe that being a little weird, you're doing fine on this part. It's the graphing that freaks you out. But what's going to help you a lot on the graphing is the number line. So on my number line, I'm going to put my x-intercepts, which I have none, and I'm going to put my vertical asymptote, which I only have 1. So right there, I have this negative 5. So if I pick a number, if I pick a number to the left of negative 5, so like negative 6, if I plug in negative 6 right here, it's going to give me positive over negative, which means overall that's negative. If I pick 0, it's going to give me positive, positive, which means overall positive. So this is not a very overly dramatic graph here. Now, to go to graph, remember, there are things that all of this information tells you, and so if you take this holistically and just think about the graph, it can freak you out. So if the graphing is stressing you out, listen to some of the things that I'm saying about how you're supposed to know, but it will help you the most if you've actually attempted to graph this before you walk through it with me. All right, so here is my first, or my only vertical asymptote I have here at x equals negative 5. 3, 4, 5. And I always just make them a little fatter so that you can actually see them on the board, but colored pencils could maybe help. I know not everybody's a fan of color, but when you're doing this, you're welcome to use the colored pencils if that helps you. And then my horizontal asymptote is at y equals 0. So make sure and draw it in, even if it's an axis, you need to be able to tell that you drew it in. So I've got my two asymptotes drawn in, and then I need to plot any points that I have. Well, I don't have a whole lot of stuff here because I don't have any roots. The only point I had was my y-intercept, which I don't really have because it's a hole, but I still need to graph it. So it's 0, 2/5, which is like right about here. I'm going to make my hole so that I know what's going on. And then to think about what else I might need on my graph here. I know from negative infinity all the way to -5, it's negative, okay, the whole time, which means that it's probably coming like this, right? But I can get a couple of points if I want. Let's see, we'll pick -6 if I do a little x, y. I'll pick a -6. Well, -6 is going to give me 2 over -1, so that's a -2. So at -6, I'm at -2. If I pick -7, at -7, I'm at -1. That looks like +2 because of my y. So y, that's really a -2. All right, so at -7, I'm at -1. So that kind of tells me my shape because it's negative this whole time. Right? It's negative this whole time, something like this. All right, so now I did not have any tangency or togetherness. Since I didn't, I know I'm not starting down here on the other side of the asymptote. Since there's no togetherness, I have to come up here from positive infinity. I know that from -5 to infinity, it's positive the entire time. So it's not going to cross this asymptote here. So it's going to come down. This kind of looks like it almost crosses it, but it's just really, really close. So I start up here somewhere. You could pick another point over here if it helped you, but I know I have to start up here. I know I have to kind of go through that point, but not really, and continue on like this. So there you go with that graph. Okay, so this is going to end part 1.